we are. So I'm gonna try to walk through this, and I fucked up the video before. Like I was building TP like down here and just talking about it, and you just stared at the screen. Epic fail. Let's remove. So I got a black box, mission, surface birth, and this allows me to pick a node, and particles per second, 25. That's fine. Put the lifespan at 300. Keep them alive. Let's create another one with. Do we put them to raindrops? Yeah. So raindrops, dynamics, velocity. Because we want them traveling in X, just going across the screen. 0.3. Look that up into direction, and put a 1. And speed and direction, so we can fiddle with this. So let's just go 50, 25, variation angle of 4. So just breaks them up just a little bit, and there they go. Vroom. Too many particles for speed spec. I'm gonna go 5 particles a second. So there we go. Going way too fast. I'm going to create the random walk, and raindrops. I really wish you could just like drag this like right there, like raindrops. God damn, that'd be nice. I have dynamics, standard force. I got these ones, so I'm going to activate that one, copy that one, deactivate. What's that one? That one's 2. This will be 1. So these I already have a large noise size and a small noise size going in here. And what I'm going to do is I got M3D black boxes here, so percent particles. Drop that in there. Got particle. I guess go remove particle. I'm gonna shift. Oh shit! Remove. I'm gonna go shift control, drag to copy. Remove these, and I got on, and then I can have different percentages for the small and big noise. So just to break it up, just that much more. So what do we have here? Let's drop in multipliers. And all that we really got to do is move the standard forces to the bottom on the side right here. So now we can control a percent of the particles, and I'll just go over how this works. The particle goes into a random, gets a number. Every particle gets a number between 0 and 100. And then basically what you do is you just threshold it, put it into the threshold 2. And then what that does is, so it's inside, so it has to be inside 0 to 25. Like that's what this number is. It's getting it from the percent. So if the particle is has the random number in between 0 and 25, then it's getting that. And so we just dial, and then so 60% of the particles have the bottom noise, and that's looking pretty ass. And that is most likely because these are at 0. So let's move the multipliers up and see what kind of motion we have. Yeah, nothing too great. Not gonna lie. So let's just play with this noise a bit. What do we have here? Speed up to 1. Yeah, so that's got a bit more of a wobble in it. Let's give. I am giving 100 just to see for now. 100. I want this is the big noise, so I only want 100 on there. There we go. So they're traveling, just, they're going wherever, a bit of wobble to them. Then what I'd like to do is I'd like to stutter the drag, and I'm going to do it a bit differently in this tutorial, I think. So, geez, I wonder if this was, I was playing with things a bit too much. Hopefully I didn't keep this off the screen, so I just adjusted these and whatnot. So let's make the drag, and I'm going to take Raindrops. I'm going to take float, and I did this in the Tesla DVD. So I'm going to go show and track view. I'm going to, oh fuck, you have to select TP. This drives me freaking nuts. Show and track view, and now I have this. I'm going to assign a controller and a noise float, and go 1, and I'm going to go 100, and I got this kind of graph. We're just going to look through this curve. I kind of like that pattern. We'll go like 50. Alright, so what I'm going to do is I'm going to absolute this. So it's only going to be between, I think, what's the highest value we got here? So the value goes to like, 20, 25 at the most. The maximum 25. So we're going to use this curve to drive some data. And, we have access to all this information. So, I got a value to time. Hopefully this doesn't blow up in my face. Value to time. So this is the noise curve. So let's rename this. And we're going to toggle on, the way we're going to do this is we're going to be toggling on a friction. Drop that there, and let's just crank this to 100. And we have the value, and we want to look up 0 to 25. How do I want to do this? I gotta think this one. Alright, cool. So I'm going to take the particle age. I'm going to take the float. This is the particle ID. I'm going to multiply it by 20. And the age is going to be looking up through the value of 0 to 100. And if this is, we're not going to turn that on. We're going to put a threshold, and if it's greater than, we'll go 15, 0 to 15. Oh, and that's right, what we want to do is we want to drop, remember I showed this curve. Do I still have it up here? No, I don't, but it was a curve, and it was going from like negative 25 to positive 25. So what I want to do is I want to absolute this, and just grab one of Joe Scar's block. Here we are, absolute. So now this has made all the negative values positive, and like that. So now we can play with this. So as the particle ages, it gets a random value, 0 to 100. Just go 300. Value 2, maybe the lifespan. I think they should do it. Nope. Definitely not. It should work. Let's debug. So use the debug. I'm going to click debug mode here, and here's my list. And I'm going to reduce the amount of particles because this debug thing's, it has to print, it prints every particle, so instead of like printing as a spreadsheet, it prints them all like, so it's got to calculate. It's bullshit. Yeah, so there we go. So now you see this flying through the values, you kind of get some of this. So I'm just going to hit escape. So now I know what's going on. And the values are in here. So instead of, we're going to test 0 to 5. If it's, this is going to be true, out on the outside of 0 to 5, or 0 to 2. So yeah, so I'm going to clear the write to debug log, turn that off. And so I saw what numbers it was getting. And that should give us a bit of a stutter. 1. A bit of a stutter, a bit more of a stutter. I'm going to turn the friction to... friction is not working. Raindrops. I think it's because the velocity is constant. So let's just try something here. Let's put a velocity particle. Let's just put it to 0 and only change the speed. So let's see what this is going to do. Should, yep, freeze. So let's turn that on. Let's see if we get a stutter. Oh yeah, yeah, yeah. So let's go 3. So there's less in that range, and there, they kind of stutter. So what we can do is we can go velocity. We can get the length of it. I think this is, there's a magnitude. Do I have a V? Get magnitude. Cool. This is from Captain Red. This is the equation. So this gives you the oh shit. The magnitude of the vector. And the magnitude is the equivalent of the speed of the vector. I also think this is the equation for length. I'm not sure, which is fine because that's the equivalent. And so we'll take the current speed and we will divide it. We'll multiply it by 0.2. So it just kind of slows down. And we're going to plug that into the speed. And there they go. There they stutter. So having a noisy curve, thresholding, so it turns on when it goes above. So I'm just gonna let's see here. I'm just gonna go show on track view, pop to it really quick, and it is noise curve. So here's the noise curve I have here. I thought it was in, but it's just above light. So here's the curve, and I absolute this curve. So whenever it's above 0.4, it turns on, and so with the age going through, it's like 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, I'm gonna stop. 5, 6, 7. Oh, I'm gonna stop. You know, once it gets 260 and it's above 0.4, the velocity reduction turns on. So as soon as it's above a certain level, that's when it goes on. So with that, what do we have here? So we should see they all stop and they all go. We don't want to do that. We want a bit of randomness. So what we're going to do is we're going to take the age and we're going to multiply it by the particle ID. We're going to multiply it by 1000, and we are going to then we're going to multiply these together by the age, and then we are going to do that. We're going to look through value. I think we need the. How are we going to do this? We want to look through time. I guess 10,000. And we're going to look through values 0 to. Is that going to work? Gonna pause thing. Alright, we're back. Sorry about that. So, this is what I'm going to do. I'm going to normalize the age, and I put the age to 0 for 100 frames. So, it is going to look through the value of 0, 1 from time 0 to 100, but I want to randomize, give a random lookup time. So I'm going to go negative 500 to 500. I'm going to add 100 to that. I'm going to drop in value 2 and value 1. I've done this before on this thing to shift. So that's value 2, that's the high, this is the low. So if the particle gets a value of negative 450, then it's going to look up the noise curve at 450. And then it's going to change that value, so we can adjust this. So this is adding 100, so it's looking up the curve, negative 450 to 350 over its lifetime. And we're going to absolute the curve, and then if it's greater than 3 or 2, then it's going to get sticky. And that should do it. So that's what I wanted to do. So yeah, they died pretty early. So let's just adjust the threshold. So I'm going to go 0 to 1. 0 to 1. So if it's outside of 0 to 1, they stick on. So I'm going to just turn the lifespan to 300. And they're sticking along. I just need more of a curve. Actually, you know what? I better do my order of operations. Threshold, absolute. So I'm going to put these in order. Value to time. Float, random, age normalize. This is float. Get magnitude, float. Move. I'm going to, so we can see it, I'm going to turn up velocity, and I'm going to multiply the value by 0.05. So it really cuts down on speed. So, and I'm getting nothing. Oh, time to fix it. Alright, so here's my problem. I was looking at 0 to 100 width, and so when my frequency is so low, it wasn't, jittering quite a bit. So, whoop, 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 and there you have it. So they stop, they go, and then so there's a bit of a jitter to them. And so the next thing we see is, now that that's taken care of, so it's the same setup, but it was just, I had to have a higher frequency in what's happening here, so it goes above the threshold, and then it goes below, like, so it changes quite a bit. So there's a quick way to make your particles drag. I'm gonna move the random walk down and see if that changes. No. Alright, okay, so back to where we were. I'm going to close this. I'm going to go 50. So you saw the difference there. So, and they're just kind of like going around all over the place. Oh, 20 minutes already. Alright, this will be part 1. Or no, this will be the motion. So the next thing I want to do is I guess I could do it in the drag. No, I can't. So what I want to do is I want to clamp the Z velocity. So in order to do that, I put in the raindrops, get the velocity. I'm just going to shift copy for quickness sake. Move that there. I'm going to drop in a point float and a shift drag a 0.3 down. I'm going to put this vector into here. So I have the velocity vector, and then I'm going to grab x, y, and then I'm going to kill the z with a 0, and then I'm going to put that into the velocity. Speed and direction, replace, and that should do. Kill the variation angle, and I think we're good. And as you can see, it's going a bit fast here, so that speed things up. Problem. Alright, here, this is how I fixed it. I had the velocity, and instead of doing anything in speed and direction, I just replaced the direction. And the direction would be clamped with this, and I just plug the velocity in like that. And this is a direction, so it's a non-unit vector. So it's like 15 in x, 20 in y, 0 in z. And we just replace the direction of that, and then we're good to go. And as you can see, they don't leave the surface, and that's kind of like all we need. And so that sums it up for the motion. So what we did is I was just looking at how I did it here, and it's like, oh yeah, just direction. So born particles, set the velocity, put random walk on them. Here's the drag. This one's better than the last one I did. This is much more controllable. I like this one a lot more. So the stutter, and then we put clamp Z, and then that is it for the motion. And now we can go on to the look. So 23 minutes, long time, but I could have done it faster, but I kind of fucked up.